Hello, this is Jishan from JC Tuition, and today we're back with another math tutorial for you. And today we're going to be talking about the modulus function, and we're going to be talking about drawing modulus graphs, inequalities, solving graphical solutions, all of that business. But before we go on to do that, we need to consider what on earth even is modulus. So modulus, or you might sometimes hear it called absolute value, it basically makes negative numbers positive, right? So basically, let's say the modulus of 5. So this is the modulus or the absolute value, these two lines. So the modulus of 5, well, to make 5 positive, it's just 5. Okay, pretty simple. If I would say the modulus of -3, well, like I said, the definition of modulus is to make negative numbers positive, so it just makes it 3. Okay, so if I were to do this as a notation, say we was trying to work out the modulus of x, so any number, well, if x is greater than or equal to 0, so a positive number like 5, well, it just stays as x. But let's say x is a negative number, so less than 0, such as -3, well, we just times it by minus of the x. We just put a minus in front of it, because -3 times the minus makes it a positive 3. How to use it sort of basically with numbers. But how do we draw modulus? Well, let's just start off by drawing y equals modulus of x before we delve into the questions that I've put below. Well, what we do is simply ignore the modulus just for a second. We just start off by drawing y equals x. So what would the graph of y equal x look like? I'm going to draw it in blue. Well, it just goes through the origin. It's just a straight line graph, right? When we're doing the modulus of x, remember we're making all negative numbers positive. So essentially anything that's below the x-axis, we're just reflecting it in the x-axis. So actually, if this is y equals x, let me draw another pair of axes for y equals modulus x. Then the part above the graph, above the x-axis, stays positive, but we're reflecting anything below the x-axis. So do it in red. So all of this is going to be reflected upwards. So it looks like this. And that's called the reflected branch, and this is the unreflected branch. And yeah, this graph is y equals modulus of x. So do you think we could sketch y equals modulus of x minus 3? And also this one over here. I'll leave you guys to have a go, and then we can go through it together. Okay, so welcome back. So same sort of thing. We simply just draw y equals x minus 3. So it will cross at the -3 on the y-axis, and then it's just a positive x linear graph like this. But of course, and we can see that if we were to make y equal 0, well, we've got 0 equals x take 3, adding 3 to both sides, x equals 3, so it must cross at 3 on the x-axis. Yep, but this is y equals x take 3 graph. We need to draw y equals modulus x take 3, so I'll just draw another pair of axes here. Well, anything below the x-axis is going to be reflected upwards. So this part of the branch, the unreflected branch, will still stay. It will still jump off at 3, but everything below is just going to be made positive, like so. So now it crosses the y-axis. Instead of a -3, well, by symmetry, it's going to be 3, all right? And just by inspection, actually, you could say, well, if we know y equals modulus of x is this graph, well, if you imagine with transformation of graphs, you had brackets, a -3 means it moves 3 units positively in the x-axis. So that's essentially what it's done. Instead of being modulus x, it's moved 3 positive units in the x direction. And now we're going to sketch this. And instead of trying to do it in terms of drawing just y equals x takes 3, we're going to go for it just straight away. So let's draw our axes. Given what I just said, let's just consider the horizontal transformation first. So x plus 2, that means it's going to move, we're considering this graph here, the y equals modulus x, it's going to move left by 2 units, right? So here, but then it's going to move down by 5 units. So imagine from our transformation of graphs, if you want to look at videos of that, you can. But yeah, we're moving down by 5. So -2, -5 is where our vertex will be essentially. Yeah, so this is -2, -5. Question is, where does it cross on the y-axis? Well, simply we just make it x equal to 0, because at this point on the y-axis x equals 0. So that means y equals the modulus of 2 take 5. Well, the modulus of 2 is just 2, so that's 2 take 5. Then y is negative 3. This is negative 3 on the y-axis. So just like any sort of number expression or even algebraic expression, modulus can also be expressed in terms of inequalities. So let's consider that x is greater than negative 3 but less than 3. Well, because the modulus of x makes anything negative positive, this can concisely be written as modulus of x is less than 3, like so. It means exactly the same thing. Well, then I'll ask you, what does the modulus of x take 5 mean? X take 5 being less than 3, mean? Well, same sort of principle. It means negative 3, x take 5 is between both sections. This is what it means. It means that x take 5 is greater than negative 3 but less than 3. You can add 5 to both sides and that makes it 2 and 8 goes there. Well, let's try and draw that on a number line just for a second so I can demonstrate something. So we know that x is between 2 and 8 and the midpoint is 5. So basically what this means, and hopefully you can appreciate, between 5 and 2 there's 3 spaces, between 5 and 8 there's also 3 units. So essentially what the modulus of x take 5 is less than 3 means is that the distance between whatever x is and 5 is less than 3 spaces. So if x was 3, well, it's still less than 3 spaces to 5. If x was 2, is still less than 3 spaces to 5. And same with the other direction. So solve solutions graphically. So if we have a question like this, simply what we do is we have to draw both graphs and equate them and then see where they essentially intersect. So I'm just going to do that. Well, let's draw the modulus of x plus 1. So the graph of just y equals x plus 1 would normally just come up like so, and then cross that negative 1 and 1, go straight up. Obviously everything below the x-axis is reflected upwards because of the modulus symbol. So I'll do this in a different color. So the graph of modulus of x plus 1 therefore looks like this. Bounces off here at negative 1. So I'll say that's the graph of y equals modulus x plus 1. How about the graph of modulus of 2x take 1? Well, the graph of 2x take 1 would cross that negative 1 on the y-intercept and also come up with a steeper gradient. So we've got, because there's a 2 in front. Where does it cross the x-axis? Well, if you just make y equals 0, so let's say y equals 2x take 1. Let's make y equal to 0. Well, we've got 0 equals 2x take 1. Rearranging, bringing the 1 to the other side, then divide by 2, we've got x equals a half. So it crosses the x-axis at a half. So it will look a bit like this, and it will cross the y-axis. You can figure out as well by making x equal to 0, so just 1. So that is the graph y equals modulus of 2x take 1. And now we can solve. So where they intercept, we can see there's 2 points. There's point A, and there's a point here, point B. Probably useful to label them. So let's work out point A first. Well, on point A is the unreflected branch of x plus 1. So we can just say that's the positive version basically. So it's just x plus 1 is equal to, well, that's the reflected branch of 2x take 1. So we can basically take the negative of all of this because it's the reflected branch. It's the one we times by negative 1 to get it up here and reflected above the x-axis. So that's negative 2x take 1. Okay. And expanding the right hand side, well, we got negative 2x, negative 1 times negative 1 is positive 1. Now I can add that 2x to both sides, that's 3x, and simultaneously take away this negative 1 for both sides. So that equals 0. Therefore, when we divide by 3, 0 divided by anything is just 0 anyway. So x is 0 for this first part. They've got the same intercepts, y-intercept, so I guess it makes sense. For point B, well, it's the positive branch, the unreflected branch of both of them, so they can both stay positive. So we've got x plus 1 equals 2x take 1. So adding 1 to both sides, we've got x plus 2, equals 2x. Take away x from both sides, we've got x equals 2, and yeah, that's the other solution. So the solutions are x equals 0 or x equals 2. We can also use graphs to solve inequalities, such as this one. So same thing, you must always draw it. So let's draw our pair of axes. So let's try and draw 2x take 3. So we know that y equals 2x take 3. That is just a straight line graph that normally crosses that negative 3. But because we're doing modulus, it will now cross that positive 3. What is across on the x-axis though? Well, we can just make we can just make y equal to 0. 3 to both sides. 3 equals 2x. So x equals 3 over 2. So let's draw that. I'll do it in red. So it crosses at 1.5, 3 over 2, and it looks a bit like this. And we'll cross at positive 3 on the y-axis. I won't label that bit, I'll just label the x-axis. And drawing x plus 4, you should just be familiar with. I'll do it in dark blue. So it's just a positive line graph. Crosses at positive 4 just above this graph, and it goes down here. This will be negative 4. So I just extend this line and also extend this line. We can see that they do intercept at some point. So there's two interceptions again. We've got point A and we've got point B. Let's consider the inequality, and we're asking when is the modulus graph of 2x take 3 greater than x plus 4. Well, in other words, when is this graph, the red lines, above this graph, the blue lines? Well, we can see, if I were to really make it obvious, it's this bit here, yeah, and this bit here. So let's try and find the solutions for A and B, and then we can go from there. So for point A, similar to what we did in the last question, we've got x plus 4, of course, is equal to the reflected branch of 2x take 3. So this is the negative. To bring it up here again, we times it by -1 to reflect in the x-axis. So it's the negative branch, so that's the negative branch of 2x. Finding the right-hand side again, negative 2x plus 3. Add 2x to both sides and take away 4 simultaneously. So on the left, we've got 3x equals -1, so x equals -1/3. So basically, point A here is -1/3. All right, let's just work out what the point B is before we go further. So again, x plus 4. This time is doing the unreflected branch. Equal to the unreflected branch of 2x minus 3. So add 3 to both sides and taking away x, we got 2x take away x is just x, and then 4 add 3 is 7. This point here is 7. So when is this graph, the red line, greater than the blue line? Well, you can see whenever we move in this direction, so whenever x is less than -3, -1/3, the modulus graph 2x take 3 is greater than x plus 4. And also when we're greater than 7, this graph is above that graph as well. So when x is greater than 7, and that's our solution. So I hope that makes sense. If you have any questions, you can put it in the comment section, or also email us at jc.tuition@outlook.com. It will be in the description, our email. You can also visit our website for plenty of more maths resources and other subjects to help you in your studies. All right, goodbye.